Welcome everyone online to our February Customer Insights webinar. First, I'd like to check that the audio is fine. So if you can say something in the chat that you are hearing me, so I know everything works. Audio is good, perfect, great. Thank you so much. Awesome. Also, for everyone to know, this webinar will be recorded, like we always do with these sessions. And after the session, we will send you the link so you can watch the recording and you can share it to your colleagues if you like. So that's good to know. All right. So I'm your host today. I'm Riina. I'm the product marketing manager at Solibri. I'm here with my colleague Lauri Luoma. Lauri will help if you have any Solibri related questions today. Hi, Lauri.
Hello, everyone.
And today's agenda. So today we have Karl Fitzpatrick from Auckland Airport presenting the role of the client in improving building information quality for asset management purposes. So an asset management angle this time. And in the end, after Karl's presentation and Solibri demo, we will have time for your questions. So you can send your questions at any point during the webinar to the chat. It will help us a lot if you tell us who the question is for. Is it for Karl or is it for us at Solibri? So yeah, but we will then cover all the questions after Karl's presentation. Now, before we start, there's a quick poll we'd like to run. So this time it would be great to hear about your projects and how you are utilizing BIM for asset or facility management. So I'm gonna give you a little time to answer this poll. Now, roughly half of you have voted, so let's wait a little while more. So far, it looks that over half of you utilize BIM for asset management in some projects, but very few in all projects. A few seconds more. Okay, I think we're starting to get the majority of the votes in, so I'm gonna close the poll soon. All right, thanks for voting. Let me show you the results. So, as you can see, over half, yes, some projects, third, not in any projects. And yeah, so this is interesting to see. There are not that many who replied that you use it in all projects. So that's maybe you get new ideas from this webinar and you can start using BIM in asset management more. So yeah, without further ado, I will give now the floor to Karl and let him share his thoughts on this subject. Welcome, Karl. Great to have you.
Thank you, Riina.
Online.
Just share my screen.
Yep, we're seeing.
You can all see my screen?
Yeah.
Yeah, so interesting survey there. It's not surprising that not everyone is using BIM in the asset management phase yet. I think it's early days, but we'll discuss how we're doing it at Auckland Airport. So first of all, thank you, Solibri, Rena and Lauri for the opportunity to present this user case study. And welcome to all of you from wherever you are across the globe. I understand some of you are probably up late or up early, and some of you are probably at lunch. I want to start today by saying that I won't be going into detail about how Solibri is used during design or construction, but will instead look at it from the perspective of a client. And I've purposely decided not to go into too much detail on the technical how-to side of using Solibri, and recommend that if you are after any tips and tricks, that you're best to join the Solibri Society or watch some of the previous webinars. Instead, I want to take this opportunity to show you how building information is used beyond the design and construction stages, and some of the challenges that we face when doing it within a large and complex existing facility. It's quite different from doing it from a greenfield new construction site and deciding at the start of the project that I want to do BIM for asset management. So before I go much further, I'd like to introduce myself. My name is Karl Fitzpatrick. I'm the Building Information Manager at Auckland Airport in New Zealand. Bit of background information about myself. I studied architecture for 5 years at Victoria University in Wellington, New Zealand. And then after that, I then migrated to Helsinki in Finland and worked at AW2 Architects. And this is where I first came across Solibri about 10 years ago, and found myself in Helsinki, which is the home of Solibri, and had never heard of the concept of IFC, had typically worked in the native files of using ArchiCAD, and then was told use Solibri and exchange information with IFC. So it kind of opened up my eyes to what actually IFC was, the benefits of working in an open format and structuring data, and also from the perspective of Solibri, just seeing how powerful it is once you have proper structured data, like what you can actually then find within the models using Solibri. After this, I then was working on the design side for doing large hospital projects, and realizing that we had these complex information models that could be used beyond the design phase by the client, but there was sort of little interest from the client about actually in the design phase about how they could use that information. And then I saw the opportunity back home in New Zealand, where I'm from, to work at Auckland Airport to basically implement building information management from the start. And it was sort of a sandbox environment where they'd explored it with a few projects, but it wasn't really integrated into any enterprise-wide system. So I then moved back to New Zealand, and then after about a year of being there, I then moved back to Helsinki and worked remotely from here for family reasons. And for the last 2.5 years, I've actually been working remotely from Helsinki for Auckland Airport in New Zealand. So a lot of this has been done from the other side of the world. And just as a side note, I consider myself a digital native and have been modeling primarily using ArchiCAD since I was in primary school, through a much older brother who introduced me to the benefits of modeling things and trying to automate the production of 2D documentation. So I've lived most of my life in this BIM and 3D world. A bit about Auckland Airport. We're located at the bottom of the earth, as far away from everywhere as possible. And as an airport, we've obviously been severely impacted by COVID, and particularly the fact that we are an island, so isolated from the world. It's given us as a country the opportunity to shut our borders and keep COVID out. So in the context of my job, we often now talk pre-COVID and post-COVID, because prior to COVID, we were experiencing 21 million passengers per year through our international and domestic terminals. And this had grown 6 million passengers over a five-year period. And now post-COVID, through our international terminal, we're getting less than 1,000, if that, per day. So only a couple of plane loads of people per day, while our domestic passengers are actually, that's running close to capacity, but nothing like what it was prior to COVID. And why are we even doing BIM at Auckland Airport, and how did it come about? So here is a view of what we were planning to do between 2017 and 2044. So we had every coloured block here is a new project, and prior to COVID, this was our master plan that we were working towards to deliver new terminal expansions, new roading networks, runways, hotels, potentially public light rail, warehouses. So we had a huge range of infrastructure and all sort of climbing over top of each other for space and having to demolish existing facilities or parts of existing facilities and tying in new projects. So to have a better way of gathering information about what designs were happening, how construction projects were progressing, and then at the end of the whole process, trying to improve the quality of our as-built and operational information. So BIM played a key role in keeping track of everything and making sure that we understood what was going on. And also to get to BIM, it's basically, from our perspective, it's a evolution of information management and hasn't really come from just a specific focus on building. So we've evolved from, 10 or over a decade ago, being a paper-based system of information management where traditional 2D plans were stored in a room with someone there looking after them, and if you needed information about a building, you'd have to go to that person, much like you do with a librarian, to get the information out. This obviously didn't make much sense longer term, and it was then decided that they would scan the documents and then move them to a digital system. So, but you're still in a file-based world where you're just storing digital copies of paper on a server and then having to retrieve know what page that information sits on. The next evolution was then to take that 2D information and shift it to a CAD environment where you then have combining multiple drawings into one to make better sense of it. And then the next step beyond that was then linking that information to the data. So that's where we then shifted to a database system around GIS, so Geographical Information System, where you can have a line or a polygon and that's linking to information. So it's a much better way of people finding information. And now within the airport, a lot of the information can be found via a map. So our GIS map is viewed by about 1,500 to 2,000 people per month, views per month of people looking for information. So there's a real appetite within the business to find information based on location rather than trawling through files. And BIM, we're kind of in the transition of a file-based world where we have individual native files or IFC files. And then even though each of those is a database, it's still just an individual file and we're sharing files. So we're gradually progressing towards more this idea of a database model where we have the model geometry and then it's separately managed. The information is managed in a separate database. But the beauty of using Solibri at this stage is that we have all these hundreds of files and we can pull them together into one Solibri model and effectively create that database view of the model. And regardless of when and where the model was made, we can then start to make sense of that data. And then the next evolution is going to be linking the data, and often it's called digital twin, but I'm not a huge fan of the word, but it's more when we have various databases around the business, it's then being able to link that information back to the geometry. So it's really important that we have this accurate building model that we can then tie to all of our other information systems. And then the longer term view is that ability that when you have structured data, and we've checked it through Solibri and can check the quality, you can then start to run scenarios and simulate fire escape scenarios based on accurate building information. So within the airport, we have a team called the Spatial Information Team, and effectively this is our goal or our sort of value within the business, is that we transform spatial data into business value and help improve full lifecycle asset performance. So we sit within a wider infrastructure team that's responsible for delivering or planning, delivering, and then maintaining assets. So to have a view of that full life cycle of the asset is very important. And this quote from the founder of Esri really sums it up from a business and a client organization that owns significant assets. Is knowing where things are and why is essential to rational decision making. So all this comes back to being able to make confident decisions about our buildings, our large assets, and having the right information at the right time in the right people's hands. And for those that are unfamiliar with GIS, I know like before I went to the airport, I knew what GIS was, but not in great detail. And understanding this GIS world sort of taught me a lot about BIM and how information was managed better. So within GIS, typically everything's mapped with points, lines, polygons, and annotation. Whereas in the BIM world, we're typically dealing with objects, elements, spaces, and solids and properties. And you can effectively look at each as a similar thing. So a point could reference a center point or a particular location within an object, or we could then extract an object to a point and then translate the data between the two systems. So Solibri is quite, like we've played around with Solibri in the sense that we can do an information takeoff and get the XYZ location of an object, and then it's just export that out as a CSV file and drop it into GIS, and it's there in the right location. So that transition of data between the two systems and being really flexible is key, but to do it, you need to understand these basic principles of how data flows between the two. So, you know, an example is in the natural world, we map everything with polygons to show water depth, or lines to show contours, polygons for isobars, and then we have points for information for like places of interest, and then we have attributes. So it's not much different to BIM. And from a client perspective with BIM, that's what we're trying to do. We're trying to map our built environment in more detail than what we have currently in GIS. So it's taking that next step from mapping all of our landscape features and basic building information to then getting a more detailed view and tying information across our entire campus to its location, which then enables everyone to find it easier. So, and here's an example from screenshots from, well, been photoshopped up a bit from Solibri, but the different components in the building and understanding where they are. And here is a view from our GIS system, and what I mean is that we have all these, currently within GIS we track points. So we have check-in desks, we have sign points. And to think about the next step and why we're using BIM is to then think, okay, we have that same sign in a BIM model now from the design phase. How do we then at the end of a project get that information, but so it still exists in BIM but can also be shown as a point in the right location in GIS, and we can then still have all the information attached. So it's really just efficiency of using information and not having to replicate it between systems. And this is where Solibri's key is that we can use it to check that the quality of the data is in a way that we can then use it between our BIM and GIS systems. And when people talk about digital twins, like for example, we already have within GIS, we can click on a point that is a sign and see the live feed of that sign information. And then you can imagine that in the future, if you have a digital model of your building, there's no reason that you couldn't just stream that into the geometry. So it's kind of that sort of thinking where we could have a real digital replica of our building that we can then use for better planning, understanding, wayfinding, escape scenarios and situations like that. So I think the use cases are quite broad and endless. And a key component of all this is having open data. We have so many different systems. The key is being able to have a data set that can be used across multiple systems, and then we can also change one system within the wider network of systems, and it's not going to impact the overall workings. So this is where we're building our system around, from a BIM perspective, or building perspective, around IFC. And in terms of the practical nature of that and how it fits into our software environment and where Solibri sits, I think this diagram sums it up well, that we have, when we're working, this environment here is our internal working environment within the airport. And then we have a layer, which is a published data environment layer, which is where what we provide to our supply chain to deliver information. Then we have our delivery teams, and then they're free to then use whatever tool they want and set up their own internal data environment, provided they then deliver it back to us in a IFC and native format, and then we can then bring that into our enterprise environment and then do what we want with whatever systems we want as we please, and we can change these systems out as needed. But here, Solibri is key in terms of our model federation, quality checking, classifications, and the ITOs, and feeding back to the supply chain what they need to do to their models to make them better. And we're also currently using it as a Solibri Anywhere as a viewer for those that need it, like design managers and project managers who need a more detailed view of the models that we're receiving. And where it sits in the project information flow, because we're dealing as a client with the full asset lifecycle from the moment that we decide we need to build a building all the way through to operating it. Solibri plays a key role in this, from concept design through to the operations phase, and checking purely from or mostly from a data perspective rather than like a clash coordination perspective, because that's the role of the supply chain. So our architects and engineers, they are responsible for ensuring that the building is built efficiently and on time and under budget, so they should make sure that there are no clashes. But from a client side, it's more, we're interested in the end data. We're going to own those models post construction, so we want to make sure throughout the process that they're tracking in the right direction so that we receive good quality models. In order to do that, we have developed the asset information delivery manual, and then which explains all of our location requirements, how we should structure building levels, spaces, and our expectations around, defining basic things such as the load-bearing status, fire ratings, element location. And we've been inspired by the Dutch basic ILS to then create our own basic information delivery manual, just to let people know, okay, if you deliver this to this minimum standard, then at least we have data in a way that we can use it beyond the project. And within that, the more detailed asset information delivery manual, we have all of our element requirements, our LOD ratings at each stage, and then the attribute that each element should have at the appropriate stage, with the idea that we're getting the information we need at each stage to answer key questions from a client perspective, and then at the end of the project we're getting quality information that can be used in operation. So as of today, we haven't had too many projects that have gone through this full cycle because of COVID putting a stop to most of our projects. But at least through these early design phases, we saw positive results from our suppliers starting to follow these requirements and regularly delivering information. And we have two buildings at the moment that are sort of going through this handover phase, and it's producing some interesting results and positive. And a key point when we have so many projects is actually defining the locations of models and making sure that they then, when they do come into Solibri, that they just drop into place without any work, so that any of our staff could open two models together and they're spatially located in the right coordinate system, and there's no translation required. So as part of that, we've developed a campus-wide survey control network, which at the start of a project, the model managers and surveyors can choose the points that they need to define their project origins, and then tie that back to our survey grid. And then when construction goes on, they have the same grid to verify the location of their data. And then we're providing a data environment in which the suppliers can then share the information with us. So at the moment we had prior to COVID, we had at least 15 projects which were all regularly sharing IFCs, which in most cases they were geolocated, so we could download those and then drop them in to Solibri, and they'd be located in the correct spot. And this is really key to actually have that environment up and running, so that the project team see a need from a client side to actually deliver the information how it's asked for. And then as a client, you can just at any moment go in there, access that information, and you don't need to be like deeply involved in their internal data environments such as BIM 360. They can just deliver you an IFC, and then we can utilize Solibri to then view that model. In terms of how we use Solibri, it's been also an evolutionary process where at the start, it was mostly just consolidating data and just viewing data in relation to each other as a federated model, and not doing too much in terms of rule checking. So it's just making that data accessible and viewable, because we had close to 100 models and they were all in different coordinate systems. If you open two models up together, they weren't next to each other. They could be miles apart. So it was a big process of getting our native models to align, and we didn't cheat in the way that we didn't just translate them within Solibri to the right spot. We actually went back into all the native models and aligned them so that when we export them out, they go to the right spot. And then once we had them consolidated, then we could start to make sense of the data by organizing it using classifications, before then enabling us to move on to rule checking. And then eventually, it's when we know that we can trust certain aspects of the data, we can then do ITOs and know that they're right. And then, of course, communicating back to the model team what needs to be fixed. So as you see here, like each phase, we're using obviously BIM authoring tools, Solibri Anywhere for viewing. We have classifications to help organize the data, rule checking for automation, ITOs, and then Power BI for displaying those ITOs. And then for communicating, we're using either just straight BCF files that we're emailing, or linking up to things such as BIM Collab. And here you can see what that looks like in Solibri. So, and I'm going to jump to the live demo shortly, which will give you more detail. But up the top left here, we have our federated models. We're then organizing the data, showing different systems in different colors to make it easier to understand, automating checking processes to make sure models are accurate and the data is actually structured properly, running calculations such as door schedules, and then also using the communication panel to communicate back to our internal team or external partners what needs to be fixed. So now we'll jump to the live demo. So here we're in Solibri in one of our domestic terminal model. This has mostly been done in ArchiCAD, but we have some models that have been produced in Revit, so we're across multiple systems. But what I want to show you from the client side is sort of what information are we interested in, because of course during construction it's around avoiding clashes and making sure that the building is going to be constructed correctly, but after it's been built we're not so concerned with that. So it's more, okay, how do we make sense of the building? So for in a lot of cases it's simply the spaces are the key element. So we can start to look at our building from a perspective, okay, what spaces are air side and what spaces are land side. We have disclosure areas which are for reporting. We have a system, well, airports have a system of charging. You can charge airlines for certain things and you can't charge them for others. So you have to be able to report specifically what spaces are used for aeronautical purposes and what aren't. So we need to be able to visualize those spaces and then calculate those values. So it's using the spaces to actually get that information easily, and then we can also export the same view of the data through to GIS and know that it has those same values embedded in the geometry. We're also looking at the usage types. So where are airport lounges, where are airport services, where are circulation spaces. So we're visualizing all the different ways that we use space. Where are fire evacuation routes, or what spaces are part of the fire evacuation routes. This could be then used in the future for simulating scenarios of, okay, in the event of a fire, run to the nearest fire escape route and take the nearest fire exit. So it's understanding all of those aspects of the building, which then enable new use cases of using the models. Again, fire evacuation zones, understanding those. And again, these are visualized in GIS but they're just like a big polygon. And in the future, we want it so that we can just extract this information straight from the models we receive at the construction handover phase. We can then just run them through our processes and then update our GIS maps and the maps that we provide for like improving our fire safety. And then here's an example which we could do in Solibri, is looking at leasable, looking at all the spaces that are leasable and then by area. So you might have a tenant who, the scenario could be that you have a tenant who's looking for 50 square meters of leasable space. So then you can quickly see within the building, you know, what spaces do we have that could be suitable. Because a large part of what we do as an airport is primarily leasing out space. So having a real understanding of what spaces you have is quite key. And then we have type. So in terms of information takeoff, you can then, you know, quickly produce a room schedule, show all this information, and then we can provide our team with a record of all the spaces we have in the area. And then the next step with that is going through to Power BI, and you can then, you know, import that Excel from the ITO and then start to create interactive dashboards around what space they have. So people that don't necessarily, not everyone needs to view things in a model, they just want facts and figures. So this type of view of the data, you know, simplifies that view of the Excel. And a lot of times people want to see this data, but being able to structure the data in Solibri is key to being able to make these accurate and trustable. And then jump to another model. So from the design perspective, you know, we have at all times we have this terminal that we're managing the building for, and we're trying to keep this, well, improve the accuracy of our existing building model. But then we will have design projects going on. So we had, before COVID, we were undertaking over 2 billion New Zealand dollars worth of development projects just on the terminal. So you could then, it's a significant amount of work that you want to be able to see how it relates and how it's going to have an impact on the building. So by people following our standards within the supply chain, they could then just deliver those models to us, and we can then just drop them in and see how they're going to interact with our existing building, and, you know, we can show how things are going to go together. So here we have, like, this model has a good 400,000 square meters plus of building modeled, and Solibri just churns through it. So it's really easy to cut sections and take measurements and really look at those in the design phase, look at the constructability issues and how we interface with our existing facilities. And then on top of that, we can quickly turn those off. And then we can also start to look at the building from, you know, again, seeing those spaces that we have and classifying them how we want to view them for calculating the right areas, seeing where the airside retail is, or there's baggage handling. Really get a sense of that space, and then again, bringing that through to Power BI and being able to see a dashboard of that. So here we've actually added another level of information, which is pulling the material from the space information. And so then you can see, okay, how much space have I got that's vinyl, and what are all the spaces, and, you know, what's the makeup and what's the total area, so you can see quite quickly what we have. And then other useful things are, you know, looking at when we have so many different systems running through the business, not through the building, and being able to understand, you know, what, not all cable trays are the same, so understanding which ones are for data, which ones are for electricity, and just classifying that information so it's much easier to see than looking at 2D plans. And filtering out the MEP components, and you can just see how many different components are there. And you think post-construction, the challenge of actually managing all those and, you know, making sure they're maintained, reporting them for regulatory purposes. Like every year we have to show that the building meets its building warranted fitness. So understanding where things are, being able to then go through the building and make sure you've ticked all the boxes is important. So having all this in a model is a great improvement on just 2D information. And now I'll jump to just this other model where I can show you the model process for how we use rule checking. So as this is an existing building, some of the information has come from construction projects where they've handed over as-built models. Other parts of the building have been done as scan, so laser scanned and then modeled and then delivered us those. Others it has been modeled from GIS plans because that's the only information we have, and there hasn't been a real need to go and capture it in more detail yet. So we have, in this one building, have a lot of different levels of accuracy of the data. So here we've got this classification, which will then show you, which elements are from construction handover models, design models, fabrication models, historic 3D models that we don't know much about, and then what's been scanned to BIM. And then by being able to classify those things, we've then been able to then create a rule check, a rule if this works, because we'll have situations where we'll have a beam or a duct or something modeled within a construction model or a design model, but it hasn't been verified. And then we go out and we do a scan to BIM process, and then we actually locate that object. So what we want to be able to do is compare. Solibri enables us to quickly compare. Okay, find me all the beams which have been classified as scan to BIM versus everything else. And so this rule here will then quickly identify all these locations where we actually now have duplicate elements. So we have the green is from the scan to BIM model and the orange is from the design model. So this now we can quickly create a communication or a report which can be sent to our model team to say, okay, you need to go through and remove the design model. But the thing is, within a scan to BIM process, they'll only model what they can see 100%. So they don't make the assumption that this beam goes all the way through to here. So there's now needs to be a process where they would actually go, okay, this is the actual location of that beam, but we need to, based on the design information that we have, we can safely say that it extends to here and here. So they can then go through, fix that up, and then remove the lesser verified element. So over time, we then will be able to try and reduce the count and then have a more highly verified model. But it's quite interesting to see that our scan to BIM models are coming within tolerance of some design models or construction models. So it's good to show that people are building things as planned. And the same with same with columns. It's the same process, because if we were to do a count of information now, we would have duplicates. So it's key to make sure that we're not doubling up information. Another good example I have here is our doors. So, if we do a door schedule, we typically just make the schedule and then assume that everything's a door. But what we noticed was that there are actually some things have been modeled incorrectly. So the Solibri rule identified that we just did a search for all doors above a certain volume, because a door typically isn't going to have such a large volume. So we made it like greater than we did a classification here. Where we identified doors based on their volume, I can't find it. And said, find any door that's greater than 0.5 cubic meters and show me it's too big, or show me anything that's less than 0.1, because it probably means that the door hasn't been modeled correctly, or it's not actually a door. So this rule quickly identified that, hey, these canopies are actually being modeled within Revit as an object which has been classified as a door. So now we know to go back into the model to fix that up. And then we have situations where we have things which would show up on a schedule as a door, and we can say, oh, we have 3001 doors, but actually it's not a door, it's some element that's been incorrectly classified as a door. So the key really is to be able to quickly find those things and then go back to the model and fix them. So this is where, from our perspective, we're using Solibri to improve the quality of that model, and over time we then have a much more accurate view of our whole building, and we can then confidently take off quantities. We can use it for reporting, we can use it for analysis to plan how we structure the building or where we locate retail and things like that. So back to PowerPoint. So just to finish off, I just want to think, okay, if we have all of our building information structured in a way that it's similar is on a map, so like Google Maps, where we have, it knows what's a main road, it knows what's a highway, it knows what's a lane. If we can structure our buildings in a similar way where it knows what everything is and it's actually accurate, then it will then enable us to actually search our buildings more fluently like we do currently on Google. And I think that's, for us, that's where this is heading, is that we want to be able to find information based on plain language search. And I think using Solibri to help get the models to that point is a key part in our process. So thank you, and I'll just open for questions.
Thanks so much, Karl. Really interesting stuff. So yeah, I already have a few questions that have come into the chat, but please, yeah, if you have anything you want to know, send those in, and it will help us greatly if you point out who your question is for. Is it for Karl or is it for us at Solibri? So let's start with the first one. There's a question that who is involved in creating the master database for Auckland Airport's infrastructure, and what is their authority? Is it one team or more than one team? Who verifies the quality of the data input, and who maintains and audits the ongoing process of creating and using the data? So that was a long one, but I hope you got it. Yeah.
So I'm just trying to expand it so I can see the full question. So from our perspective, we're trying to define that. It's a work in progress in terms of defining what our information structure is, and we've got the asset information delivery manual, which has a current list, but there's, of course, we find things that are missing. But the idea is that becomes the master data structure, but then the building database itself at the moment is sitting in that file-based world where it's still within native models and the IFC export. So we haven't yet moved on to the position of having a separate database that would contain all of the building information in the same way that our GIS system currently works, where everything's in a database and then it links to the map. So we're heading in that direction, but it really needs the data to be structured properly. In terms of the team, where we sit within the spatial information team, which is within, as I said, in the infrastructure team, and our role is to capture that asset information and then distribute it back to the business. In terms of the auditing of verifying the quality of the data, that's again within our team, and utilizing Solibri to be able to check that and speed up some of those processes. In an early design phase of a project, it could just be through quick visual checking using classifications, but then as you get deeper and things start to be modeled correctly with the right information, then you can put those classifications to work in the rule sets and speed up the process. And in terms of auditing, ongoing process of auditing and creating the data, that will be within our own team, and also like working with external suppliers. I hope I've answered that question.
Thanks. Yeah, then we have a question about the fire evacuation. How were the fire evacuation defined natively? Has that been an extra space each, or how was that approached?
So that is within the native file. Bring it up. I assume you can still see my screen.
Yeah, it's still sharing it.
So that's just the fire evacuation. So if we pick a space, it's been mapped to just the PSET common. So within ArchiCAD, it's just creating that, having an ArchiCAD property, and then within the IFC translator, then mapping that property to the PSET common space. So here it just as a true or false value. So it started out as a ArchiCAD classification, then it's been within the IFC translator mapped. Say use this field as a Boolean, true or false, and then within Solibri we're just viewing it as show me all fire evacuation routes that are true. So it's quite straightforward.
Great. So next question would be, what is your long-term vision for these models?
Long-term is that we then have like one building. We have a complete data set of our key assets. So primarily the main focus at the moment is terminals, and then any larger commercial building, that we have this accurate data set, which then isn't spread across multiple places, but that building information can then be linked to other databases. So for example, our building management system, or maintenance order system, or GIS database, but it's just that we have one building data set and we're not duplicating it across multiple systems. So people can just, ultimately it would sit in some like data warehouse type thing where people can then call, say I want to see space information, and they would be able to call that out. And then the next big step would be that simulation type thing, because an airport is quite a controlled environment in the sense that you know how many planes are coming when and how many people are on those planes, and you know the processing times at a point in time through immigration or baggage claim or whatever. So being able to plug that stuff into an accurate model would then mean you could simulate, like have a look ahead of the day of how things are going to look, so you can actually operate a terminal more efficiently and provide a better customer end user experience and customer experience, so that things work smoothly, because we all know how frustrating it is going through an airport and spending our time in lines and running to planes. So it's trying to, I think that I see that we can, if we structure our data right, that's where we can get to. But it's, I think, still a few years off.
Okay, thanks. Then we have a question. Have you used the model setup IDM from BSI to implement geolocation between GIS and BIM models?
No, so we've only, these are all located within the national coordinate system, or the local coordinate system. So it's between BIM and GIS, it's literally like these files are all located in relation to each other correctly and in relation to the coordinate system. So we just drop them in and say, this is this coordinate system, and it knows it puts into the right spot. So we haven't positioned our own grid, our own survey network separate from the coordinate grid. And this does mean that these models are far from origin, but they're not far enough that it's caused problems.
I can also take a few questions. Thanks, Karl, for great presentation. There's related to this GIS. There's a question: can Solibri compare IFC and GIS files? So, well, the answer is basically no, but there might be some, because Solibri is really just to import the IFC files and checking the quality of the IFC files. But I guess there could be some workflow where you would export the GIS coordinates and import from a spreadsheet to Solibri classification, and then you could maybe compare them. But I'm not that familiar with the GIS files. I don't know if you, Karl, would it be any like a would that be even possible?
Yeah, one example that we've tested, I can't show you it here.
Yeah.
We're just showing here. So we've done here are all the doors. There's like over 3,000 of them, but effectively each door, you could, that diagram I showed earlier where I had the points and the objects, if you treat at some point in that door there's a point and you just want to get that to GIS, because it doesn't need to be millimeter accurate, it just needs to be roughly in the same location on the map. So what we've done is just created a ITO which has every door individually with a GUID, its floor type, and then some width and height information, but then we've got this global X and Y. So then by exporting that out here, you can then just, GIS will read that Excel file or read it as a CSV, so you can then just bring that information in, and if that value there is relating to a coordinate system, then you can just say within GIS, okay, that's in our case NZTM, and it will position it in the right space, so it will put a dot on the map. So that's, and you can do the same with like any point type object like sprinkler or a piece of furniture. You could locate it that way in GIS.
Yeah, I think if it's possible from the GIS software, if you can export this similar kind of list of the coordinates and also the width of the component, you can import that into a classification, and then you could compare the values with the rule. So in that way, it would be possible. But
yeah, okay, so that would be useful for comparing if you've got doors that are already modeled or represented in GIS, and you want to compare what you have in BIM.
Yeah,
and they come from two different data sets. You might want to reconcile the two. So you could do that extract from GIS, have your BIM model, and then say like find these points within a certain distance and see if they're the same thing.
Yeah. So there's some, that would be also maybe but importing GIS files is not like possible, correct?
But you can take GIS data and use another tool like FME to translate the data to IFC. So an easy example was like the spaces that you could map all the spaces to within GIS data, effectively just polygons. So if you've got a GIS data set that's just polygons, you could use a tool like FME to say convert all those to IFC spaces and add whatever information you have in GIS, you could attach it to the IFC space.
And then there's two bit similar questions also to Solibri, like does the data from Solibri model need to be exported as Excel file for import to Power BI, or can one integrate Solibri and Power BI? So there is actually an ongoing discussion in Solibri society with in the developer platform side. So with the current APIs, it probably is possible to have also, but at the moment it's I guess the way Karl has done it is by exporting the Excel sheet and then importing that to Power BI, and also the same for any automated reports from Solibri to SQL. That's also something that with the APIs is probably doable, but not like out of the box.
Yeah, so I guess in case you're interested in these APIs, you could join our forum, Solibri Society, if you're not a member already, because there's a lot of information and discussion on those.
Yeah, it's good to sign up to the Solibri Society if you're interested in any tips and tricks and also this API and developer like side of things.
All right, thanks both. There's a couple of questions also about this scan to BIM. Like, what is scan to BIM model? Is it the point cloud model? And then there's questions on how is the process of scan to BIM? Is there an automated process or is it a manual process?
Yeah, so for us, it's the fact that we have gone and had someone, a surveyor or BIM company, scan the building with a laser scanner and then use that within the authoring software, so Revit or ArchiCAD, to then produce the model. So they're not, and they're modeling it specific for the project that we need. So they may not model every single thing, but they may model just the main areas, such as the walls or beams and large pipes, but they don't necessarily go into like the minute detail because you could get carried away. So it's starting with the point clouds and then just using that as the reference in the same way that you would use like an old CAD drawing to model up. You're just using the point cloud. That just gives us a more accurate view of what's there. So for example, we've had these models here, which are classified green, but the front of the building here has been produced as scanned to BIM, and then you can see that there's like, we have some old design structural models that need to be removed because there's new structure there. So it's uncovering all that information. And then they'll model ducts. And one thing I was going to show you, which I forgot, was in Solibri, where Solibri has been helpful, is that we have examples where you have a beam or a column that's been modeled using a beam, the beam tool in Revit, and maybe like having it's a vertical beam rather than a column. So, but all the information within the object is saying that it's a beam, despite it being a column. So with Solibri, we were able to say, like, compare the length of the beam with the bounding box height, which would be its vertical height. And then if it's the same, then identify it, because I need to go back and fix up the modeling and actually classify it as a column. So Solibri is very useful in that type of stuff, which you wouldn't typically find from a visual perspective.
Yeah.
Are there any more questions?
Yeah, we can go to the next one. So there's a question that how much computer power is needed to have this big model running?
I think I have
know
like,
if you remember.
I've just got a i7 8th gen processor and 32 gig of RAM. Seems to be working fine.
Yeah, good.
It's yeah, it's a game. I have a gaming laptop, but I found that a big challenge that we have internally is that a lot of as an airport, most people, you're not an architecture or engineering office, so most people within the business have just laptops for doing PowerPoint presentations and sending emails and looking at Excel charts. So it's a challenge to actually get this size model to them within like a Solibri environment. So that's where we need to sort of sometimes strip back the view or just only share a couple of models that they need, rather than they don't, always need the whole building. And then those that do need more powerful view have to just get a better laptop.
Yeah, we do have quite many questions still here in the chat, and we're a little bit over time. But Karl, do you have time to still discuss a little while longer?
Yeah.
Great. So we will run a bit over time today, but there are so many good questions still. So let's see. Next one is about PSET comments. So how much do you rely on the PSET comments? How many attributes you prescribe the individual planners? I don't know if I understood this correctly.
Yeah, so for example, like because of a lot of these models are historic, they haven't all had all the information updated correctly, and some are missing. They haven't been exported with PSET. So it's like Solibri is able to help us find that there. But it's basic. At the moment, it's the basic information such as the position and the load bearing, and some basic like space information. Nothing too detailed yet, but it's because most of these models you see are from historic projects before we had defined a detailed standard. So it was these newer projects which I showed in this model that we're starting to properly structure the information. So there wouldn't be more than like 10 bits of information in the common PSET.
Mm-hmm. Okay. Then what about how do you cope with other formats but IFC, like for example STP? Or do you?
Typically, like I haven't had to deal with STP, but we've had like the classic one was the baggage system, which was in which was as a DWG, 3D DWG, and then bringing that, actually used ArchiCAD to bring it in and then geolocate it because Revit wouldn't open it properly. So we brought it into ArchiCAD, then re-exported it out to IFC and managed to actually add a whole lot of information to it to classify components as we wish. So it was typically we have enough tools that we can get between different formats. So we use either ArchiCAD or Revit or FME to translate between different formats and get it to IFC.
Yeah. There's also a question if we can reply to these questions after the session, if we don't have time to go all of these through now and send the answers with the recording. Absolutely, that's what we always do if we run out of time. So don't worry, we will definitely go through everything after the session and check that we have replied to everyone. And if we missed something, then we will get back with and send the replies with the recording to everyone.
Yeah.
Maybe we can have a couple of more and then do that like said afterwards. So there's a question, is the export and dashboard used by the users or most by your team to make it ready for the future?
Yeah, at the moment it's mostly by our team just to look at how we can view the data, and then eventually we would want those hosted so that people across the business can see. But at the moment, the thing is the data isn't to the point, like isn't accurate enough that I would want to have it out across the wider business. So we're really using it at the moment to just get it set up how we want it to look, and then trying to improve that data quality. Because if you push something out to a business where they rely on information and it's wrong, you basically like kill every future opportunity, because they won't trust your data set. So really, the key at the moment is getting up the quality and the trustworthiness of the data.
Great, thanks. There's a question about in what way can Solibri be used to check the traffic simulation in an airport?
Doesn't, in the way that I explained it, it's not really Solibri's role, but I think Solibri's more helping to make sure that you've got the data structured. So if you plan to do simulation, it's making sure that you've got your fire doors correctly identified, you got your fire corridors identified, and then maybe you could do basic like distance to evacuation routes, but in terms of actually like simulating it with avatars, then Solibri isn't doing that at the moment. So you'd need some other platform.
Yeah. Then there's also an interesting question related to, since you talk about the long-term goals, how to find, correct, and update information to make the data model more accurate and easy to search. But how do you identify what the real benefits are compared to the cost to maintain a team / budget needed to update the various data models? So basically, how do you measure and articulate the benefits to make all this happen?
In our case, I think it's like the fact that we use them on the biggest benefit's been just using them on future design projects, because we had so much work happening, like it was tying into the existing building, so it's pretty easy to see how it helps. It's really, we've done exercises where you try and put monetary value on this stuff, but it's too complicated because there's too many moving parts. But in terms of our team, like before COVID, it was just 2 of us, and now we're just 1, just myself. So internally, we haven't had a huge team. I think we were planning to grow it, but COVID's put a bit of a stop to that. But that's where tools like this, where we can automate a lot of the checking and stuff, if we can improve that through automation, then it reduces the cost. And also using IFC means that you can actually hold on to the data without needing to maintain it necessarily in a native file if there's nothing happening to the building at a particular point in time. And I think COVID's a case in point where things have kind of stopped a bit at the airport, so there's not a lot of maintenance going on. But because we have it in an open format, we know that we can just have it here. We could effectively cancel basically a lot of our software licenses and still have access to that data, and that's key. But in terms of value, it's really hard to say.
Yeah. Okay, maybe one more question, and then I think we need to start wrapping things up. The facility management system you are using to manage all asset data at Auckland Airport, is the name of the system something you can share with us? Or is it confidential?
No, because it's not really, it's not one thing. It's like, this is the thing you realize when you're dealing with a big piece of infrastructure like this, is that you will never have one thing that does it all and manages the building. And facility, like some people say facility management and they think about facility maintenance and actually repairing the building, whereas in other cases management is more around like actual space optimization, using the building, trying to increase the value of the space within it. So whereas that's a different system to the maintenance system. And then you have another system that's managing the HVAC and building services system, and then you have another system managing the baggage handling system, and then you have all these tenants within your building who have their own system. So it's like, at the end of the day, we're never going to have one FM system to rule them all. It's like going to be, and that's where I talk about this linked data, is it needs to be that, you know, we have a building data set that where each element that we need to operate the building has a common ID, and then that's then linked. All the other systems could then just call that as needed if they need a view of that asset, or if they need the data from that asset. So I think that's the key here, is like recognizing that you're creating a building information data set that then feeds into all the other systems.
Yeah, great to know. All right, let's wrap it up for this session. But like I mentioned earlier, we will definitely check all the questions through, and if you didn't get your answer now, we will deliver it for you with the recording of this session in a few hours. So thanks for your patience, and thank you for being so active, asking a lot of great questions. Great to have all of you on board, and thank you so much, Karl, for your great presentation and all the interesting information you shared today with us.
No worries. Thanks for having me.
So next up, in March 17th, we have our next customer insight session. We're going to have Case Bridge Hospital, then presented by Janne Kivelä from Harris Kisik Architects. So save the date. You will also get a link to register for this session after this session today. So you can already mark the day in your calendars and reserve the time for that. Otherwise, that's it from us today. Thank you so much for everyone once again, and hope to see many of you next time. Thank you.
Thank you.